Welcome to the MTC studio. This is the last episode of 3 episodes on the modern data platform, Real Insight for your business. My name is Ross Laforte. I'm a data scientist with the Microsoft Technology Center based in Chicago. What I do is I work with some of the largest customers to understand their business needs and challenges and design solutions based on those that exactly meet their needs. Also, what I do is I actually work with the product teams at Microsoft headquarters. I take a lot of the feedback from our customers and I provide it back to the product team so they could enhance the product and make our products better and better all the time. So we take a lot of the feedback very seriously to keep improving the product. So I actually go out to Seattle at least several times a year to provide feedback and decide on what features, capabilities in the product we want to implement. Okay, so one of the things we see in around key trends in the business these days is that the cloud has become a key player, a key enabler for companies to improve the processes, to be a leader in their business, to better understand their customers. So as you can see, IDC here says that cloud actually will enable $1.6 trillion additional business value to companies that actually do implement it and leverage it for its agility, for its scale, for its cost. Also, 10% of organizations expect to have highly profitable business units just by selling data, because data is becoming a very important key asset that a lot of customers have that they could unlock and make it available for sale for others. And we are seeing that as another trend happening. And with the capability of the cloud and scale that we have available, that's becoming more possible. Third is SQL Server has a 46% market share. And the reason is why we're the most utilized database in the world is because we understand what you all want and need, and we actually implement in our product to make it better, to make sure it meets your needs. Also, SQL Server is easy to use and has all the capabilities of the product are built into SQL Server as a one-shop solution. So I've been with SQL Server since the very beginning. Actually, we kind of grew up together. I was part of SQL Server when it originally shipped. I was working actually as an intern at school still, and I got access to SQL Server because it was brand new. It was a brand new database. They wanted to get their name out, and I was working for a large telecom company as an intern. And at that time, I got access to it, and I started working with it, and I found out it was a very powerful database system that I knew it was going to make a big difference in the world of databases and technologies. So when I got out of school, I continued working with SQL Server, and I continued working with Microsoft and continued improving the process, improving SQL Server over the years, and providing feedback back to the product team so they could make those type of improvements. As you can see here, I actually started with SQL Server 3.x, but as you can see here, from SQL Server 2000 to 2016, an evolution of new technologies and capabilities that we have been implementing release after release to keep making SQL Server the best database out there. And I'll show you next where we are in Gartner's Magic Quadrant because of what the feedback we have gotten from everyone, like people like you, and implement it back where to improve it. So if you see SQL Server 2016 over there, I am going to talk a lot about the mission critical performance, and going to talk about the cloud, hypercloud capabilities that we implemented to improve SQL Server in those areas. Okay. So what we do with SQL Server is one of the things I'm actually proud of. Like I said, I started with SQL Server from the very, very beginning. And I saw it grow up from a baby. Is that in Gartner Magic Quadrant, we are on the very top of it. We are above Oracle. And this is October 2015. Okay? The reason we actually got there is because we understood what customer needed. We kept listening to what customers' feedback and kept improving the product to make it what it is today. So we started as a database system, but we kept growing and growing it. Number one performer, okay? We also understand that your data is very critical and very important to you. So we make sure that it's highly secureable. So we're 6 years in a row with the least vulnerable database out there because we make sure that your data is fully secure inside SQL Server. Okay, and also we have implemented R inside SQL Server for data scientists. And the reason we do that is because R is becoming the language of choice for statistical analytics. We want to make sure it's available to you. As SQL Server is a market leader in databases, if we implement it inside SQL Server, then more people have access to the R capabilities right from within SQL Server itself. So I've seen all over the years how we have made a lot of progress to keep improving it, keep it making what it is today. And you know, in a way, I am very proud of that because I've been part of that journey from the very beginning. So one of the things I like to suggest to everyone, and as a best practice, is if you want to provide feedback to us, you should go to Microsoft Connect. There's a website there, connect.microsoft.com, and provide feedback. There's two ways to do that. First of all, if someone, let's say, has, you first search if others actually have provided that feedback. If they have, and you find the link that it has, usually you'll see a vote. And you can vote. So you can add a vote to it so that we know how many people are asking for the same feature. If it's a new feature that you don't find anything, you create a feedback, and other people will vote. And what we do is we actually compile the number of people voting, the size of the companies, the impact that feature would have on those companies. And based on that, we decide where we want to target our dev resources to provide those capabilities. And a lot of capabilities like JSON support, always on capabilities that we have implemented in SQL Server, encryption, really a lot of them came from feedback that we hear from customers here and from this forum. Okay, product teams watch this forum and will answer you with any questions and any feedback that you provide them. They actually listen to it. Okay. One thing that I like to also tell you about SQL Server, and like I said, I've been around for SQL Server for a very long time, is that up to, you could say, SQL Server 2012, up to 2008, you could say that customer would come to me and say, can SQL Server scale to meet my business needs? Can you prove it to me? Since SQL Server 2012 and on, nobody asked that question. I have not had a single person come to me and say, can you prove it that it could scale? Can you prove it that it could run my business? Because you know what? People understand that we could scale. They know we could scale to as good as anyone else out there. They could rely on SQL Server to run their business. What they come to me nowadays is ask me, let's design a solution with SQL Server that meets my business needs. So these are some examples of scalabilities that for customer examples that that I'm annotating here. Some big customers like SAP, GE Healthcare, Pros, Fujitsu. It just shows that SQL Server could scale to the top of any database system out there. Another thing I like to be proud of is the scalability when you combine it with Windows 2016. I'm sorry to say Windows 2000 Server 2016. You could scale SQL Server to 12 terabytes of memory, okay, and to the maximum cores available on Windows 2016. So if you have a large enough server and you need to really scale, you could actually cache your whole database in memory. That's the capabilities available in SQL Server. Scalability, we could scale to the very top of the largest servers available. That's why customers don't come to us and ask, can we scale? We could scale. Here's an example of very large customers running SQL Server for mission-critical Tier 1 applications. They rely on SQL Server day in, day out to run their business. Okay, and some very, very big names are here. There are Fortune 500 companies. Also, because SQL Server is an easy-to-use, easy-to-learn database system with a lot of capabilities out of the box, very agile. Thousands of ISVs support SQL Server as the product, as the main database system for their customers, because it's easy to install, easy to license, easy to use, easy to manage. So again, a lot of top ISVs leveraging SQL Server to develop their products, and these ISVs, you could say that they make SQL Server the first platform of choice to deploy their application. So in the development team of Microsoft, we kind of look at SQL Server in three pieces, three pillars. Because there's so much in the product, we need to focus developers on each one and make each one a best of breed. So we have specific development teams focused on hyperscale cloud to make sure SQL Server could work and interact and scale into a hybrid cloud solution. That means is that all the tools and all the capabilities work consistently either on-prem or in a cloud or in a combination. SQL Server would actually operate with a single common tool sets. Another area of SQL Server that I'm not going to talk about here because it was discussed in a different episode is deeper insight across data. That's the business intelligence side of SQL Server. Again, another group of individuals are actually using, of development teams are working in that area. The third area is mission critical performance. You could say that that's the area that the majority of SQL Server is deployed and working and running. It's running mission critical performance means it's running line of business applications day in, day out, where companies depend on it to run the billions and billions of dollars of companies every day. And they depend on it to have a highly performant, mission critical solution that they can rely on every day to run that environment. And we take those three pillars very seriously, and we implement solutions around those to make SQL Server the best solution out there. So some of the things to note about SQL Server, I mean, I'm going to talk about the top 7 here, is Microsoft is the recognized industry leader when it comes to databases. We take security very seriously. Like I said earlier, we are the least vulnerable database out there, 6 years in a row. We provide groundbreaking performance and scale, and I'm going to show you some examples of what we have done with SQL Server 2016, because that area, we felt that there was a trend that we want to take advantage of within memory capabilities. So we have the fastest in-memory technology on the planet across workloads. We also be able to run your mission-critical applications day in, day out, and you can rely on it, on SQL Server, to be there for you, to keep running your business. Also is able to integrate, SQL Server is able to integrate from on-prem to cloud and run as a hybrid solution. And more important, everything is built in. everything is built into the solution. You don't have to buy anything extra. It's all part of the solution. So one of the areas that we have improved SQL Server, and this started with SQL Server 2014, and we further enhanced it in SQL Server 2016, is in-memory LTP. What we find that there's a trend, okay? First of all, computers are getting bigger and bigger, more and more CPUs. Memory is getting very inexpensive. But disk really becomes a bottleneck for most of these large database systems. Because a lot of the times, a process is waiting for disk I/O. And the disk is so much slower than CPU and memory. So the trend in the industry was, let's move more and more of the processing to in-memory and use disk just to store a permanent store of your image of the data. So in case the system were to go down, you have a copy of the data to recover from. But let's run in memory, because we could run a lot of times faster. So that trend, we took advantage of that trend. And some examples. With that new capabilities, you could see a company called Bwin able to scale their application from 15,000 requests per second to 250,000 requests per second, because they leverage SQL Server and memory capabilities. And you know what's easy about that? It's all part of the solution. It's all built in SQL Server. You don't have, the application doesn't require any rewrites. It works as just as if it was just another table in SQL Server. It just, instead of being on disk, the table lives in memory. Okay? So SQL Server is optimized for in-memory capabilities. It's optimized for hardware with a lot of memory, and could scale to meet the needs of the largest customers, because we could scale with in-memory capabilities like you see here. So again, the reason we did that is because of the capabilities that are available with the hardware and inexpensive hardware and memory these days. So what SQL Server provides with in-memory LTP is that you could take a table and actually store it in memory. Okay, so all the operations are happening in memory, and only the transaction log and the data streamed for backup to disk in case the server were to fail. You could recover from disk, but all the operations are happening directly in memory. The whole table just moves into memory. Another thing we also did with SQL Server within memory is we now allow you to natively compile store procedures that access the in-memory tables, which then means that instead of having these store procedures going through parsing and optimizations and then executing the query against a table, natively compiled means it's compiled to code, which means it's all that parsing, optimization is already all done for you, and it runs a lot of times faster. And I'm going to show you an example of that. Some of the things that we improved in SQL Server, which I would in memory, that really made SQL Server more adaptable for in-memory, was we increased the memory footprint for in-memory tables to 2 terabytes. In SQL Server 2014, it was at 256 gig. So now you could store up to 2 terabytes of in-memory tables in SQL Server 2016. And another area that we did a lot of improvement, and I think this area actually probably increased the adoption by far. Like one of my friends was saying, is once Microsoft increases the T-SQL surface area, which means supports more of the T-SQL syntax and in-memory tables, more customers could adopt it because they don't have to rewrite those pieces of code. With that, means is the adoption rates improved tremendously. Okay, and that was one of the things we did with SQL Server 2016. Increase that T-SQL surface area, so that we have less restrictions on what operations could run against in-memory tables. Also, what we also did with SQL Server 2016, and this was started in 2014 too, is we give you the capabilities. In SQL Server, there's actually a report that you could run. Here's an example here on this slide that helps you identify tables that make sense to move them into memory. Okay, like for example here, you can see that the report based on usage, it identified these two tables to be good candidates to move into memory. So you don't have to move everything into memory. You could pick and choose what makes sense. Okay, I'm going to show you a quick example of running in memory and what it could do. Now I'm running on my laptop, not the most powerful system in the world. Okay, so typically when you're going to run in memory, you're going to run on a big server with a lot of memory, a lot of CPU. So it's not comparable to this, but just to see the extent, the gap between running on disk and running in memory. Now, here's what we did to an airline system that if we wanted to get more performance out of it. Let me stop the system. Then let me migrate a couple tables into memory. Those are the hottest table, the ones that get used the most, the ones that users actually access the most, okay? Into memory. There we go. Now let me restart. So we were running about 500 average. So let's see what happens when we kick it off and rerun again. Okay. Now I just moved 2 tables into memory. They were the hottest table. That's a table where everybody were accessing to get the best deal, to find the best sale for the airline system. So we went from 500 to almost 9,000. And that's running on my laptop. Okay. Not even on a real server. So let's do another thing. Let's now take it one step further. I'm going to stop this. And I'm going to migrate the stored procedures that access that tables. So I don't have to, so I kind of eliminate the compilation, the parsing of the stored procedure of T-SQL. I'm going to compile to code. Now we were going about 7,000 or so, 8,000. Let's see what happens. So this is the kind of performance that customer was getting by just leveraging what's the capabilities of SQL Server 2016. Just scale, just massive scale to meet their business needs, to meet the sales their Air Asia or Ryanair or Air New Zealand was running. Okay, so here's an example. What's possible? Okay, I'll stop this and move on. Okay, another thing we did for in-memory was that in-memory LTP is really designed for OLTP type of workloads, more line of business applications that run your business day in, day out. But what about if you want to do reporting? It doesn't do very well against reporting because reports kind of requires to scan lots of data. So we wanted to make sure we could address that solution as well. And we implemented updatable column store indexes on a table. So we could take a table, a row store table, and flip it over into a column store, into a column, row-wise to column-wise. Which means this, the data, because columns tend to have more redundant data, we could compress them more. Also because when a table scan comes around, typically it's asking for specific columns. We could skip all the other columns so the query is not requesting. So between compression, between skipping the columns you don't request, versus a row store has to come across and read every row to get the column it needs, you're actually eliminating a lot of I/O in that is required to run very large queries. Also, what column store indexing does is segments your data, almost like an index. So it knows what data lives in what part of the segment. So they have to search every segment of the column, and only the ones that it needs to get the data. So between the capabilities, we could see performance up to 100 times faster for reporting operations. So In-memory LTP runs OLTP systems. Column store index runs reporting. Okay? And you could also say that easily we use it 10 times or more compression. It depends on your data. I think 10 is a fairly conservative number. I see much higher. So one of the things that customers have asked us is, because of agility these days, you want to see you want to be able to write data to the database in your line of business application, and then be able to read it right away and report off of it. One of the challenges that typically happens with database when they do that is that line of business applications that do OLTP and running reports against an OLTP database, they typically impact each other because of different workloads, and they actually impact negatively against each other, and most likely the OLTP system suffers, and the OLTP system is what runs your business. Okay? But there are scenarios where customers need real-time data coming out of your OLTP system because they need agility. They need to make a decision now. They can't wait until the data moves to their warehouse and decide onto it. Businesses run at the speed of light, and that's kind of required. And to handle some of those scenarios, customers came to us and it kind of asked us, how can you solve that problem for us? How can you help us run their warehouse reporting workloads right off of LTP operation database? Because I need to get the data, but every time I do that, I impact the system, and it's not working well together. So the Microsoft development team, we all got together, kind of thought about how we could actually build a solution to handle that. And a lot of that was also feedback from the Connect. Okay, again, very, very good resource for you to go back and make sure you input your data there. So we came up with a solution where we now allow, in SQL Server 2016, what's called operational analytics, is that you could run column store index on a row store or in-memory table. So an in-memory table or a row store table, you could attach a column store index to it. So you could kind of blend both worlds together. So therefore, your line of business runs off of the in-memory table. The reporting, their warehousing, are supported through the column store indexes. So you get both capabilities out of the same structure without having to lose performance, without having to sacrifice any performance. So what we did, combine both scenarios into one system. This doesn't mean doesn't mean that all your reporting should come off of the OLTP system. It just means it gives you a way to run those scenarios when you need real-time data right here and now, and you don't want to wait until it moves it to their warehouse, it gets exported to their warehouse to run reports. You could get the data right now and take actions for your business. And you could see that now with that technologies, you could get 30 times faster transaction within memory LTP, and you could get your reports running from minutes to seconds. So you could take the action in real time with operational analytics. And again, it's part of a solution. It's part of SQL Server. It's all into the SQL Server technology. Another thing that we gotten a lot of requests, almost every company I talk to is using it, is availability groups. It shipped with SQL Server 2012, and where this came from was a lot of what customers were asking us was, how can we have? I like to have high availability and disaster recovery both in a solution. The problem before 2012 was, and before this technology was, you have to blend in a couple technologies to make it happen on SQL Server. So which means that you have to implement maybe failover clustering with log shipping, data mirroring with failover clustering to get HA and DR together. The problem with the two technologies, they're not really they're two independent technologies. So they necessarily don't behave together. They don't know about each other. So you have to kind of adjust that they could behave together just so that they could actually run in some consistent manner. So we were asked, how can we have a better solution that we could have everything HADR into one solution with one management tool to manage it and easy to use. So in 2012, we shipped a technological always availability groups, part of the always-on capabilities. What this does give you is the capability to have a primary database system that's run your business, and then you could have up to 9 replicas that primary database is synchronizing with. And those could synchronize in synchronous or in asynchronous mode. And you could choose, pick and choose. Some could be synchronous for DR to a location far away, different data center, or even it could be synchronizing to an Azure VM running SQL Server, as you could see here. And then you could have HA and high availability having another server that you could fail to, and then having other servers far away from each other where you, in case of disaster, you could recover from. The whole technology is built as one solution, runs through one common tool sets, installing, using it, managing, troubleshooting. It's all built inside Management Studio. You can also integrate it with PowerShell. And another thing we did with this is that we provided what's called a listener, where the application only has to connect to the listener. And as the database fails over to another replica, the application fails over with it, because it's listening to the listener, and the listener fails over and points to a new replica. So you don't have to worry about reconnecting. It's all part of it. So we made it very easy to implement. Many of our customers are using this every day and relying on this for high availability and disaster recovery. As an example, here's the Lufthansa systems. But there's almost every customer I talk to has implemented in parts of their organization. With SQL Server 2016, we allow you to have a load balancing number of secondaries to load balance reporting. So for example, primary runs your database systems. It runs your line of business. You could actually enable your secondaries, which are all these secondaries here, and you got up to 8 secondaries and 1 primary. And you could actually enable them to run reports for you. So in other words, you could offload the primary reports to the secondary. So with SQL Server 2016, we're allowed to round robin your reports to all the secondary servers that are out there. Which means is you could scale out your reports and offload reports from your primary server, give your primary server more scale, more performance. So because it's got less work to do. And another thing that we heard from customers is that in SQL Server 2016, we are deprecating data mirroring and replacing it with availability groups. And because data mirroring supported standard edition and availability groups up to SQL Server 2014 did not, we are now in 2016 allow you to run availability groups with standard edition. It has some limitations, just like mirroring had limitations when you run a standard edition. But you could do also, you could set up a HA or DR site using availability groups, and don't have to rely on data mirroring, which we are deprecating. The nice thing about this solution, unlike other solutions, is it fails over very fast, because the servers, the primary and the secondary, they're all running all the time. So basically, the failover is just a matter of just switching over to the other server. So they're always running. It's not like you have to shut down one. The primary shuts down and moves on to the other. They basically just hand over the baton to the other. So failover is within seconds. Barely noticeable by any user or for an application. Other things we've done with SQL servers to make it more a good citizen with the cloud is that we implemented capabilities to work better with the cloud. One of the things we did was with availability groups, we could set up a VM, a replica in the cloud, and allow you to fail over to that replica anytime you want. Okay? So for example, you could have a DR in the cloud, which means in an Azure cloud, which means that if your server were to fail and you lose all your data, let's say your data center were to fail, something happened, really a major disaster, you could rely on the server in the cloud that has all your data. Okay? So that's, and we made it so simple to use where we have a wizard that allows you to implement that solution. Just click, 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 and creates an environment in the cloud and joins it as part of the availability group to the on-prem. And you're up and going. No downtime. All this is done online. Also, what we help you do is SQL Server also supports backing up to Azure blob storage. So for example, let's say you have a lot of small databases and you want to have a location, a backup location, where you safely store your backups. And also a location that's far away where in case something were to happen in your data center, you could recover those backups. So SQL Server 2016 backup commands now support backing up to a URL. A URL means it backs up to Azure Blob inexpensive storage. So what some of our customers are doing, taking a lot of their small databases here and there, and they just backing up straight to Azure Blob. By doing that, they reduce their costs because oftentimes they're running on a SAN on-prem, and backing up to on-prem means that they're incurring very expensive storage solutions that they own on-prem. Rather than by backing up on cloud, you could reduce the storage need on-prem and use that storage on-prem for other solutions. So that's all become all part of built-in SQL Server. Okay. Another thing that we actually have done with SQL Server is, again, talking to a lot of our customers. What happens is oftentimes our customers say, well, you know, I have a 10 terabyte database, and I'm only using about 300 gig. The rest of it is archived data. It's all dormant data, but I have to keep it around. Either I got regulatory restrictions, auditors might come in and want to report the data. Maybe once a month I need to run a report to get that data. So I have to keep the data online, so I can't get rid of it, I can't move it. I need to have it. And I can't back it up, because if I back it up and then I need it, I have to restore this backup somewhere and do some work. So we heard that repeatedly from customers after customers, asking us, how can you help us solve that? So with SQL Server 2016, we came up with a solution, and it's been very highly